Good day, students. I'm going to record the review on grid on transformation. Let's define first the transformation. In 3.7 graphing logarithmic function, transformation is the process of moving a figure from the starting point, the starting position, which is the pre-image, to another position, which is the image, without changing its size and shape. So there are types of rigid transformation. First is the reflection. Reflection, a transformation that is a mirror image of the original figure through the line of reflection. So if this is the image, if this is the pre-image, then we are going to transform it from this line, then the pre-image becomes this image, another position. So we call it reflection. Let's go forward to another type of rigid transformation, and that is translation. The meaning of translation is a transformation that shifts or moves the figure's location right or left, up or down without changing its size and shape. So let us transform, for example, this is the pre-image. We are going to translate it, okay, moving the figure to down, it's downward or left or right, downward to the right, so without changing the size and shape. So this is an example of our translation. Okay, next, let's move to glide reflection. Glide reflection means a transformation that combines reflection and translation. So glide reflection is a combination of reflection and translation transformation. So for example, if this is the pre-image, we are going to glide it. So let's reflect first. So after reflecting, then let's translate it. So this is now the image. Alright, so let's have transformation involving exponential function. Okay, first, let us enumerate first the following reflection based on the logarithmic function. Okay, first, the graph of f of x is equal to log negative x base b is a reflection about the y-axis of the graph of f of x is equals to log x base b. Okay, so next, let's have the graph of f of x is equal to negative log x base b is a reflection about the x-axis of the graph of the f of x is equal to log x base b. And then next, the graph of f of x is equal to negative log negative x base b is a reflection about the y-axis, then about the x-axis of the graph of the f of x is equal to log x base b. Okay, so from the first statement, okay, we have we are going to show the reflection of the graph of this function. So if the original function, if this is the pre-image, the f of x is equal to log x base 3, then the reflection is the reflection about the y-axis. This is now the image of the function log negative x base 3. Okay, so the pre-image has its points. Okay, so the points of the new image, or this image will be 1 0 3 1, and then 1 0, these are the points, 1 0, and then 3 1, and 1/3 negative 1. This is the points of the function f of x is equal to log x base 3. Okay, so if you're going to get the points of the image of log negative x base 3, then the image will be, then the points are the following. Negative 1 0, we have negative 3 1, and we have negative 1/3 negative 1. Okay. So next, sketch the graph of f of x is equal to log x base 3 and f of x is equal to negative log x base 3. So based on the second statement above, okay, the graph of f of x is equal to negative log x base b is the reflection about the x-axis of the graph of f of x is equal to log x base b. So as you can see, for the example number 2, if this is our pre-image, the f of x is equal to log x base 3, then the reflection of this is about the x-axis. Its reflection is this one. Okay. Alright. So it is a reflection of the x-axis. Okay. Next, let's move to example number 3. Let's sketch the graph of f of x is equal to log x base 3 and f of x is equal to negative log negative x base 3. So, based on our third statement, okay, the graph of f of x is equal to negative log negative x base b is the reflection about the y-axis, then about the x-axis of the graph of f of x is equal to log x base b. So it is like the glide, no? Okay, so if you look at it, this is the pre-image. If the reflection of this is this one about the y-axis, then the reflected image will be, of course, we are going to glide it. So reflection about the x-axis will be this one. Okay. Alright. So it is a reflection of the x-axis, then about the y-axis. Reflection of the x-axis. Reflection of the y-axis, then about the x-axis. Okay. Next, let's proceed to the horizontal translation. So, horizontal translation will be based on the following. The graph of f of x is equal to log quantity x plus c base b moves the graph of f of x is equal to log x base b at c units to the left. So we have a plus sign here, plus, always remember that it is c units to the left. Okay. Next, the graph of f of x is equal to log quantity x minus c base b moves the graph of f of x is equal to log x base b at c units to the right. So minus sign will be c units to the right. Okay. So now, let's try to compare or sketch the following graphs. So first, if this is the given, and then the function, this one has a plus 4, then the C, then the graph will move C units to the left. So if this is our pre-image, then let's move to the left. 1, 2, 3, 4, because of this C units. 4 plus 4 going to the left. Okay. Let's proceed to the next example. Okay, as you can see, we have our function. The C units is with minus sign. That means we are going to move the graph 2 units to the right. So if this is our pre-image, then we will move it with C units is 2 to the right. So 1, 2. So this is now the image. Alright, next, let's proceed to the example number, the next example. Okay, vertical translation. Vertical translation involves the following statements. The graph of f of x is equal to c plus log x base b moves the graph of f of x is equal to log x base b at c units upward. So, here we have the c plus this logarithmic function. Okay, so we are going to move c units upward. Okay, so let's try. If this is the given 1 plus log x base 3, then therefore if this is the pre-image, let's move the graph upward 1. So this is now our new graph of the f of x is equal to 1 plus log x base 3. Okay, let's move to example number 3. If the function is equal to negative 2 plus log x base 3, then if this is the pre-image, okay, of the logarithmic function, then we are going to move the graph downward. So with this 2, 1, 2, then this is the graph of f of x is equal to negative 2 plus log x base 3. Okay, now let's move to vertical stretching. For vertical stretching, the graph of f of x is equal to c times log x base b. Stretches vertically, the graph of f of x is equal to log x base b if c is greater than 1. So do this, copy all the x coordinates and multiply all the y coordinates by c. So let's have the pre-image. If this is the pre-image, okay, or the f of x is equal to log x base 3, then let's stretch the graph with the value of the c 2. Okay, so this would be the graph of the function. Okay, this one. Alright, so how to do it? Okay, first, if the following points of log x base 3 is 1, 0, 1 over 3, negative 1, 3, and 1. If these are the points, the 3 points of the graph, then we are going to copy all the x, 1, 1/3, and 3, and then multiply the y coordinates with 2. Let's multiply it by 2, same 0. Let's multiply it with 2, we have negative 2. Let's multiply it with 2, we have 2. So we are going to plot the points 1, 0, and then the other one 1/3, negative 2, and then the other one is 3, 2. Okay, So next, let's have the vertical shrinking. The graph of f of x is equal to c times log x base b shrinks vertically. The graph of f of x is equal to log x base b if c is less than 1. And to do this, copy all the x coordinates and multiply all the y coordinates by c. So as you can see, the the c is less than 1. So if this is the image of f of x is equal to log x base 3, then we are going to multiply the c to all y coordinates. So if these are the points of the graph, if these are the 3 points where the graph passes in f of x is equal to log x base 3, then we are going to multiply all the y coordinates with 1/3. So let's copy first all the x coordinates, 1, 1/3, 3. And then the y coordinates will be multiplied by by 1/3. 0 times 1/3 is 0. Negative 1 times 1/3 is negative 1/3. 1 times 1/3 is 1/3. So we are going to plot these points, and after plotting, we can now create a graph of f of x is equal to 1/3 times log of x base 3. Okay, so we are now ready to answer the apply the concepts. Activity number 1, graph the logarithmic functions. Thank you for listening.